In this video we will talk about correlation matrix using Pearson correlation coefficient. So, if you remember we discussed about students marks in subject A and subject B. We used stack bar chart or a bar chart to compare or box plot to compare these things in descriptive analytics. Let us look at the same data. We have 60 students marks in a subject A and subject B, same students. Okay. So, we can plot the relationship between subject A and subject B. You see that student who was scoring good in subject A definitely scoring good in subject B. Actually I created this marks with a linear relationship, say 0.93 into subject A. If you just compute 0.93 into 65, it will come like that. So, I created this marks to show there is a linear relationship. So, it is a linear relationship and it is perfect and it will be 1, like positive 1. And you know there is a strong relation between subject A. The student who scores good in subject A, that is math, they might definitely score good in science. Okay, this can be established. Let us look at the other example. We have attendance and midterm marks and the final marks in the semester. Now we have a 2 independent variable and 1 dependent variable, that is you see this is x1 x2 and 1 dependent variable and 2 independent variable. We can compute the correlation between these values, like what is the correlation of between attendance and final marks, and what is the correlation of midterm marks and final marks, right. Let us look at that. So, consider column 1 is attendance. So, let us and the midterm mark, final. This matrix is created using Excel. Okay, the simple tool available in Excel can help you to do that. So, is there a relationship between column 2 and column 1? Yes, this two relationship x and y highly correlated 0.9. Is there a relationship between column 1 and column 3? That is 0.84. This is the correlation coefficient between attendance versus final marks. If the student have more attendance, it is highly likely scores better score compared to students who has low attendance score. And so, this is the self correlation, like attendance versus attendance, or midterm marks versus midterm marks, final marks. So, obviously it is 1 if you do the self correlation, and ignore that, ignore the diagonal part of this matrix. Let us look at that. Column 3 versus column 2. What is the correlation coefficient of midterm marks versus final marks? It indicates 0.8. It says if the students score good in midterm, like in a midterm or mid-sem exams, he definitely will score good in the final exams. So, that is a final exam score. So, this is the correlation matrix which tells you the x1 and y1, x2 and y1. What is this is the correlation between attendance and mid-sem. This may not be correct because the mid-sem would have done till the first half of semester, attendance would have data till the final just day before the exam, or we do not know when you have attendance, maybe first half of semester, or you have attendance just 1 month before the final exams. But given that assumption, okay, you have attendance till only the mid-sem time, attendance and midterm marks has a high correlation, it is a 0.9. Okay, now there is a question comes in, a lot of questions, right. If I want to create a simple classifier, should I use both x1 and x2 to predict y1, or should I use any one of them? It is a very interesting question. The reason is you see there is a high correlation between attendance and midterm marks, because 0.9 is very high correlation. If the student has more attendance, definitely has a more midterm marks. If it is less attendance or less marks in the midterm exam. So, there is no point in picking both variables for our research, for our creating the classifier or predictive analytics methods. Instead, we have to pick one of them. The general approach is we use the one which has highest correlation with the dependent variable, that is column 3 with column 1, that is attendance. Since it is very simple, since attendance and the midterm marks are highly correlated, right. So, since they are correlated, we can pick one of these features for the classification of predictive analytics. Which one to do? That depends on how much they are strongly correlated with the final mark score. I would choose say I would choose the attendance, because attendance 1 is strongly correlated with the final score compared to the midterm marks. Midterm marks also good, very strong, 0.8 compared to 0.85, I might pick 0.84. So, I will choose so attendance to predict final marks, right. So, that is what I will try to do. Reason is I will try to use the best independent variable which is correlated with the independent variable for creating classifier. For these two values, it is easy to predict. For example, since there is a high correlation between attendance and final marks, it is simple. You just have to create a simple if and if else condition or some filtering criteria to figure out whether student will pass the exam or not pass the exam, or student will how much student the score using regression or something like that. Consider you have more than say 2, that is you have x1 up to x10, like you have assignment score, your midterm marks, the number of the attendance, the engagement level in the class, the responses in the discussion forum, you have a lot of other information available from the classroom environment or some other learning environment. If you have that kind of information, then having all these features to predict is may be a problem if you want to reduce the computation time. So, you can use do the feature selection algorithm. One of the algorithm is doing the correlation between independent variable with a dependent variable, then picking the strong correlated one, and also ignoring the values which is highly correlated, like the independent variables who are highly correlated can be moved out. This is a one technique which is used very widely some time ago. However, due to the advanced classifiers, we do not really care about this how to select these features to predict y1. Instead, we use other techniques which are available in the tools. We might see them when you are using the tools, which help you to pick the right features for prediction. But still, it is very good practice if you want to go for prediction. Try the correlation method with the correlation matrix, that might help you. Also, the correlation matrix, if you have say 10 columns, might help you to provide the relationship between each independent variables and how it is related, how this variables can be predicted using the values given in the correlation matrix. So, I would recommend if you have more than one variable, one independent variable, go ahead and complete the correlation matrix to get a sense of the data and see how they are related, is there any linear relation between these two variables. You saw correlation matrix in a previous slide, and I hope you understood that. Let us do a small activity. Given the 4 plots, x1, y1, x2, y2, x3, y3 and x4, y4. Given these 4 plots, can you guess the correlation coefficient of these charts, like chart 1, chart 2, chart 3, chart 4? Can you guess this? Also, if you guess it, what is the inference you are making it out of this correlation coefficient? You no need to do any calculation or something, just guess it, just try to guess what will be the value. This data is from a paper, so this is the cited paper. So, all of them have a same correlation coefficient, you might have guessed it correctly if it is good. All of them have a same correlation coefficient. Why? In a last video we talked about drawbacks of Pearson correlation, right. This actually example gives you all the details of that. let us look at it. The first one x1 versus x2, it is scattered around a linear relationship. So, there is a 0.816 relationship, it is okay, it is 0.816 good. This is not a linear relationship, right. X might be a linear, but Y is non-linear relationship with X. Still it is correlation coefficient 0.86 because there is a line which can fit all these lines, these points. So, here the drawback of Pearson correlation, that non-linear relationship is not identified here, right. If it is good correlation coefficient, you should be able to identify non-linearity also, but unfortunately there is no any metric which identifies this non-linear this kind of non-linear relationship very accurately. Here the correlation, if you remove this particular point, for example, if I remove this point, there will be a line, it will be an exact positive one. Because of one outlier, only one outlier, the value is less, 0.816. So, the Pearson correlation coefficient is sensitive to the outlier. Okay. How sensitive, that is defined, explained in this particular figure. Look at this figure, and if you remove this outlier, absolutely there is no correlation between x and y, it is 0. There is no correlation coefficient, right, it is not increasing, it is just simple 0. Because of this outlier is in a very because of this outlier, the line connecting these two is perfectly matching because this value is high and this is good, the value is 0.816. So, this tells you the Pearson correlation coefficient is sensitive to a outlier, this tells you how much sensitive it is, and this tells you Pearson correlation coefficient is does not consider the non-linear relationship. So, that is the typical figure which explains the Pearson correlation coefficient, also its drawbacks. So, in this video we saw what is correlation matrix, and we saw a plot which explains the drawbacks of Pearson correlation coefficient. Thank you.